Hey, you ever look up at the night sky and just feel this, I don't know, this incredible sense of possibility?
Oh, yeah, definitely.
Like with all those stars out there, could we really be the only life? Well, it's the big question, right?
It absolutely is.
Well, something pretty exciting has just happened. Something that has the folks who think about this stuff all day, astrophysicists, astrobiologists, really buzzing.
Hmm.
It involves that amazing James Webb Space Telescope, our incredible eye on the universe,
Amazing instrument.
and a planet way out there called K2-18b. There's this discovery that, well, it strongly suggests something truly extraordinary might be going on.
That's right. And in this deep dive, we're going to explore this fascinating news around K218b. You've pulled together some really compelling material.
Okay.
There were discussions with Professor Niku Madhusudan. He's a top expert in this from Cambridge, featured on the Event Horizon YouTube channel,
Yeah, I saw that.
and also a great summary of the findings from the Insane Curiosity channel. So our goal here is really to break down the complex science.
Make it make sense.
Exactly. Help everyone understand what was found and, maybe more importantly, why it could be such a huge deal for the search for life.
Okay, so set the scene. This planet, K2-18b, it's not exactly next door, is it?
No, not at all. About 124 light years away, it orbits a red dwarf star.
And crucially, it's in the habitable zone. That's the sort of cosmic Goldilocks area.
That's the one where liquid water could theoretically exist on the surface. Not too hot, not too cold.
But it's quite different from Earth otherwise. Bigger.
Oh, yeah, much bigger. About 8.6 times Earth's mass and maybe 2.6 times the radius. So it's a hefty world.
So for a while, scientists have been looking at it, trying to figure out, well, what is it like? And the big question hanging over it, could life actually exist there?
Precisely. And that takes us right into our first key insight. JWST, the Webb telescope, has picked up some really interesting chemical signals in K2-18b's atmosphere.
Signal.
Specifically, the potential presence of dimethyl sulfide, DMS.
Okay, DMS. Why is that name ringing a bell?
Because here on Earth, DMS is almost exclusively produced by life, mainly tiny marine phytoplankton.
You're kidding.
Nope, it's like a chemical whiff of ocean life.
Wow. So hold on. This telescope, hundreds of light years away, might have sniffed something in the air of another planet that, on our world, basically means life is breathing it out.
That's the potential implication, yes.
Yeah.
This is pretty mind-blowing stuff.
Yeah, no kidding.
And it's not just DMS. The telescope also found hints of something called dimethyl disulfide, DMDS, and other carbon-based molecules we'd expect, like methane and carbon dioxide.
Okay, so a whole cocktail of interesting chemicals.
Exactly. And it's this combination that really gets astrobiologists excited. Plus, and this is pretty wild, the reported levels, the concentrations of these things,
Mhm.
they aren't just a little bit higher than Earth. They're potentially thousands of times higher.
Whoa, wait. Thousands? That's not subtle. That sounds like a planet just screaming with this stuff.
It suggests potentially a very active source, yes. If it's biological, maybe a really thriving biosphere.
So why is DMS the star player here compared to, say, methane? Methane can come from volcanoes, right?
That's a really important point. Methane, even oxygen, can be produced by geological processes, things that have nothing to do with life. Volcanoes, chemical reactions in rocks.
Okay.
But DMS, on Earth at least, the known non-biological ways to make it are much, much fewer. Professor Madhusudan, in those discussions we looked at, he kind of likened it to the exhaled breath of ocean life.
So it's a much more specific clue, like finding a very particular fingerprint, not just a general smudge.
That's a good way to put it. It's a stronger potential indicator for biology.
It still blows my mind how JWST can even do this. Detect specific gases so far away. How does that work, in simple terms?
It really is a marvel of engineering. Basically, JWST uses incredibly sensitive instruments that look at infrared light, the near-infrared spectrograph, and the mid-infrared infrared.
Okay, infrared, like heat vision.
Sort of, but it's more about analyzing the spectrum of that light. When K2-18b passes in front of its star, starlight shines through the planet's atmosphere on its way to us.
Ah, okay.
Different gas molecules in that atmosphere absorb very specific wavelengths, specific colors of that infrared light. So by looking at which colors are missing or dimmed in the starlight that reaches the telescope.
You can tell what gases are in the atmosphere, like a chemical barcode.
Exactly. Each molecule leaves its unique fingerprint, its absorption pattern on the starlight. JWST is just incredibly good at reading that barcode, even from 124 light years away.
That's just seriously impressive tech. Okay, so potential biosignatures. But you said K2-18 isn't like Earth. I remember hearing this term, Hyson world. What does
Yeah.
that actually mean?
Right. Good question. So the Hyson concept, it's a mashup of hydrogen and ocean. It describes a hypothetical type of planet,
Okay.
one that has a really thick atmosphere dominated by hydrogen, sitting on top of a deep, maybe even global liquid water ocean.
A planet-wide ocean under a hydrogen sky.
Potentially, yes. And some scientists, actually including Professor Madhusudan, who helped develop this idea, think these Hycean worlds might actually be really promising places to find life. Maybe even more promising in some ways than rocky Earth-like planets.
Huh. More promising. That seems counterintuitive. A hydrogen atmosphere sounds pretty alien. And that massive ocean. How would life cope?
Well, it would definitely be different from Earth's life as we generally know it. Remember, K2-18b is much bigger and more massive.
Right, stronger gravity, higher pressures.
Exactly. So any life there would probably need to be adapted to extreme conditions. They'd like our own extremophiles here on Earth.
Like the weird microbes living near boiling volcanic vents at the bottom of the ocean, or in super salty lakes.
Precisely those kinds of hardy organisms. Life finds a way, sometimes in environments we'd consider totally hostile.
Alien extremophiles. That's cool. So what might they be doing? How would they live in a Hyson world?
Well, this is speculative, of course, but fascinating. Professor Madhusudan talked about possibilities. Maybe life there could use the abundant hydrogen in the atmosphere.
Instead of oxygen like us.
Maybe use hydrogen and the carbon dioxide dissolved in the ocean to fuel their metabolism, to get energy. And maybe, just maybe, DMS is a waste product, a byproduct of that alien metabolism.
Ah, so the DMS is like their exhaust fumes.
In a very simplified sense, yes, potentially.
Mm-hmm.
And the fact that the detected levels might be so high that suggests it wouldn't just be a few microbes hiding in a corner.
It would imply
Well,
a really widespread, thriving biosphere.
that's the tantalizing possibility.
Mhm.
Life potentially teeming across vast alien oceans. And it kind of challenges our focus, you know?
Yeah.
We spend so much time looking for Earth 2.0.
Yeah, a twin Earth.
But maybe the universe is full of these other kinds of habitable worlds, these Hyson planets, that are just as suitable for life, just different life.
Man, this really does make you rethink things. Okay, so we have these exciting hints, potential biosignatures on this weird, massive ocean world. What does this mean for the big picture? Is it time to announce we've found aliens?
Whoa there, hold the alien party poppers.
Mm-hmm.
Not quite yet. The excitement is real, definitely high. But scientifically, we need to be cautious.
Okay, caution.
The current detections are at what scientists call a 3 sigma level of confidence.
3 sigma. What does that mean in plain English?
Think of it like
Oh,
you're pretty sure you saw something. It's unlikely to be just random noise or a mistake, maybe like a 99.7% chance it's real. But in science, especially for a claim this big,
you need to be really sure.
you need to be really, really sure. The gold standard, especially in physics and astronomy, is 5 sigma.
And 5 sigma is.
It's like a 1 in 3.5 million chance that what you're seeing is just a random fluke. It's an incredibly high bar for certainty. So while 3 sigma is very encouraging, it's not definitive proof. We need more observations.
Got it. So it's a smoking gun, maybe? But we need the DNA evidence, metaphorically speaking.
That's not a bad analogy. And remember, the excitement isn't just about the DMS hint alone.
Right, it's the whole package.
Exactly. It's the potential DMS, plus the other molecules like methane and CO2, plus the fact the planet is in the habitable zone, plus the fact it fits this potentially life-friendly Hycesian model. It's all these pieces pointing in a similar, very interesting direction.
Okay, so if, and it's still an if, but if this gets confirmed, if they reach 5 sigma, what then? What are the implications?
Oh, they would be. Profound, just astronomical, literally. It would strongly suggest that life isn't some bizarre fluke unique to Earth.
It would mean life is common out there.
It would certainly push the needle heavily in that direction, that the universe might be, teeming with biology, with diverse biospheres. It changes everything about our place in the cosmos.
Wow. And what about the star type? Red dwarfs. I've heard they can be nasty, flare-ups and radiation.
That's a valid concern. Red dwarfs are known to be quite active, especially when young. They can unleash powerful flares, bursts of X-rays, and charged particles.
Sounds bad for life. Could strip away an atmosphere.
That was the worry, yes. That planets orbiting close enough to be warm might get their atmospheres blasted away or sterilized. But K2-18b has an atmosphere, a substantial hydrogen one, it seems.
So maybe they're not all planet killers.
Exactly. It suggests that perhaps some planets, especially larger ones like K2-18b with stronger gravity, orbiting certain red dwarfs, can hold on to their atmospheres and potentially remain habitable. And since red dwarfs are the most common type of star in the galaxy,
Finding life there would mean habitable worlds are potentially everywhere.
it significantly broadens the possibilities, yes. This finding is making scientists rethink red dwarf habitability.
Okay, one other thing. Professor Mathusahan apparently mentioned a connection to early Earth. How does that fit in?
Yeah, that was a really neat idea he raised. He suggested that maybe a Hyson world like K2-18b with its hydrogen atmosphere, lack of free oxygen, big ocean, might resemble Earth in its very early stages.
Billions of years ago, before plants started pumping out oxygen.
Exactly. Billions of years ago, before the Great Oxygenation Event, Earth's atmosphere was very different. It likely had methane, CO2, maybe not much free oxygen. And microbial life back then might well have been producing gases like DMS and DMDS.
So K218b could be like a snapshot of primordial Earth.
In a way, yes. It could be offering us a glimpse into a type of environment where life on our own planet first got started, or at least existed for a long time before oxygen became dominant. It's a fascinating parallel to consider.
That really is incredible, like looking through a cosmic time machine. Okay, so what happens now? What are the next steps to get from this exciting hint to, well, maybe confirmation?
More telescope time. The teams involved are definitely planning follow-up observations with JWST.
To get more data.
Yep. To gather more light, improve the signal quality, and hopefully push that statistical confidence up towards the 5 sigma level,
And maybe see things more clearly.
potentially. They also hope that with better data, they might be able to more clearly distinguish between DMS and the related molecule DNDS, dimethyl disulfide. They have slightly different fingerprints in the light spectrum, but you need really good data to tell them apart.
So it's all about getting more looks, more data, refining the analysis, being really, really careful and sure.
Absolutely. That's how science works, especially with potentially revolutionary discoveries.
This has been absolutely fascinating. Just thinking that we might be, on the cusp of finding life beyond Earth. It's almost too big to wrap your head around.
It really is. This potential discovery on K2-18b, the whole Hyson world concept,
Yeah.
it feels like it could be the start of a new chapter in astrobiology, one driven by actual observations, not just theory.
So as we wait for those next results, what's the big takeaway? What's the final thought you want to leave people mulling over?
Maybe this. Considering that idea of K2-18b potentially resembling early Earth, does it make you wonder if the conditions needed for life to start and thrive for billions of years, like perhaps in these Hyson environments, are actually more common?
More common than what?
More common than the specific, maybe rarer conditions that eventually led to complex oxygen-breathing life like us on Earth. Are these kinds of worlds the galaxy's default cradles of life?
Wow. That really flips the perspective, doesn't it? Food for thought. Well, if you found this deep dive into alien oceans and strange atmospheres as mind-bending as I did, make sure you follow the deep dive for more wisdom from across the universe. We will definitely be keeping an eye on K2-18b. Thanks for joining us.